Module 2, we are concerned with knowing the built heritage. That means we have to deal with documentation, diagnosis, in order to integrate all of our knowledge and understanding of the building. That means architecture, structural system and materials, given of course its positioning into the environment, into the surroundings. Of course, every building is a living organism. It has a lifetime which is determined by its behavior under the environmental loads which are exerted and by its usage. Within its lifetime, the building is changing. Is changing due to decay of materials and pathology of the structures, and we have to know very well the mechanisms that are concerning this change in order to decide when and how to intervene. This module is introduced through a conceptual approach regarding all the stages of protecting cultural heritage. That means integrated documentation, diagnostic study, monitoring, control, maintenance, quality control, and of course, after a proper scientific support for decision making, the materials and conservation interventions dealing with design, with intervention works, and with quality control of intervention works. Understanding the building has to do with documenting the intrinsic and the extrinsic data of a building, which are dealing the intrinsic data with the general information regarding the building, historical documentation, surveying, geometrical documentation, architectural documentation, structural documentation, materials characterization and mapping, and of course the history of materials and structures taking place from construction to the whole lifetime and maintenance of the building. Knowing the relationship, actually the interference of materials to environment means to know the materials environment interfaces where intrinsic and extrinsic functions are interfering and are acting, developing the decay phenomena. The documentation of extrinsic data concerns the environmental factors which are characterizing in generally the climate, that means temperature, humidity, or the wind directions, and the microclimatic factors which are determined by architecture. That means orientation of building materials in respect to environmental factors, or the position of the structure and the building against the wind directions, or the rain abrasive phenomena, the surface morphology, and the patterns of attack. The atmosphere, the water, the biologic factors are documented because they are determining the actual decay phenomena. And more or less the usage of the building is developing environmental loads and stresses against materials and structures as building environment, as interior environment, or as visitor loads and patterns. The mechanical loadings which are exerted to the materials are due to temperature fluctuations, differential thermal expansions, salt crystallization, earthquake vibration, and abrasion. How do we document the building? Documenting the building is dealing with combining documentation and diagnosis, surveying, architectural documentation, structural and materials documentation, with emphasis on alterations and interventions, are comprising the integrated diagnostic study. This is giving a complete picture of the building in its current state. For instance, the documentation and diagnostic study of an archaeological site is comprising environment and archaeological remnants which have to be managed as data either through CAD management, like for instance here in ancient Acropolis of Rhodes, or through GIS, Geographic Integrated Systems Management of Data, where the photos documenting the remnants are inserted and geographically managed. In the case of combining surveying documentation with a diagnostic study, here we can see the inclusion of non-destructive testing, which is documenting the decay phenomena through hyperlinks in the geographic information systems. Again, in the ancient Acropolis of Sarandapycho and Erymokastro in Rhodes. Architectural documentation is important and has to be included in details as here in the same monuments because either on surface or in 3D or with informations regarding surface alterations and decay, it is enabling us to perform restoration, like for instance here, where the main entrance of Sarandapycho Acropolis is resembling to the Mycenaean era Tyrrhene fortifications and might be reconstructed as seen. Historic buildings and architectural surfaces under diagnostic study permit us to understand what are the major problems we have to tackle with. Here in the neoclassical building of Mela-Palas in the center of Athens, we can understand very well how the aging of materials in a heavily polluted atmosphere is imposing us periodical maintenance and conservation interventions in order to preserve the building. The materials mapping, including physicochemical characteristics and macroscopic and microscopic morphological characteristics, might be presented as rendered through false colors like here. This is enabling us to perform not only materials but decay mapping as well, rendering by false colors the various decay patterns as in here. Not only qualitatively through the colored mapping, but quantitatively as well. We can assess and evaluate the presence of the various decay patterns in percentages and take decisions according to their importance. Of course, this is a very important study, not only on the level of a simple building, but on the level of a historic complex like fortifications, historic cities, and in this case we have to exercise a special laboratory of decay in the case of historic city of Rhodes, which is acting as a laboratory, and our students have to look in Module 3 this exercise in order to understand how we deal with an historic city or an historic complex. How do we understand the structural system? In Module 2, Topic 2.4, we may understand what are historic structural systems, their behavior and typical damages in the lesson of Professor Vigileu. Of course, everything is materialized, and in a building we have to get knowing the building materials. How do we classify building materials? Speaking of building materials, we are speaking of the main components of a building system with technical performance, bearing loads, facilitating uses, and of course this is related to building materials which are either natural or technical. In the case of natural building materials, provenance and elaboration, for instance, of building stones is prevailing. In the case of technical building materials, technology and raw materials are of main interest. The selection of appropriate building materials is a main factor to facilitate the requirements of uses. The existing knowledge permit us to characterize materials' properties, to foresee their performance under exerting loads, stress and stresses, to assess their compatibility from material to material at the interface material or at the interface of material and environment, to estimate the environmental impact of the environment to the materials, and to foresee the lifetime within which the viability of the building is secured. And of course, we can assess the availability and the cost of materials, which are determining factors as well. The evolution of building materials is related to the history of architecture. In the Neolithic period, we have mainly constructions of stone. In the early period, only stone. In the later period, brick technology is starting with mud bricks to be presented in constructions, sometimes coated with plasters. In Greece, we have allocated these architectural and material examples in Sesklo and Dimini. Urban architecture in early Bronze Age, when firing temperatures are starting to reveal, is being enriched with materials with bricks. Of course, stone foundations and brick superstructures are combined. We have the House of Tiles at Lerna, the White House at the Colonna of Aegina, where we are starting to observe internal separations with corridors and rooms. In the Middle Bronze Age, we have some architectural improvements, especially at the beginning of the Mycenaean period, when a part of houses which are now built with bricks, with roofs of straws covered with clay plaster, and we have improvements in the palaces of Agamemnon and Ulysses in the Homerian poets. The architecture is now presenting great improvements in palaces, and in the late Bronze Age we have the first Mycenaean kingdoms, where mainly, apart from palaces, fortifications are presented in history. We have the fortifications of Mycenae and Tiryns, massive works, constructions of stone, where new, more complicated structural systems are presented by vaulted tombs. The proto-geometric period is characterized mainly by new firing technologies, bricks, ameliorated bricks, and pottery. During the geometric period, wood is presented as well as a main architectural component, which is now permitting to develop buildings with upper structures made of adobe bricks and which are capable to bear loads due to the wooden constructions. We have important historic buildings and monuments, like in Thermes in Aetolia, or in other places of ancient Greek architecture, as in Samos, the Apollo Temple, and the Standing Artemis in Sparta, the Temple of Standing Artemis. During the Archaic period, we are having the presence of Ionic and Doric architecture. The pillars are made of wood, the capitals of stone, and we are having mainly Ionian examples of architecture in the Aegean region and in the Minor Asia, like in Ephesus, whereas in continental Greece, Doric architecture is prevailing. In the 5th century, the Neoclassic period, Parthenon and the Acropolis of Athens are prevailing as the masterpieces of this period, which are now symbolic and emblematic monuments of the World Heritage. The architecture of the 4th century is focusing on the construction of large building complexes. Religious architecture is generalized. Public buildings are constructed. More elaborated construction materials and structures are revealing, and combinations like the ones observed at the Mausoleum of Halikarnassos and the altar of Zeus at Pergamon are the ones that are stemming with the following period, the Roman period, where we have highlights of social imparity, residences of rich people, very impressive, but housing of massive population of great interest as well. It is the period that the evolution of mortars is gaining ground and is permitting the development of new complicated structural system. Crushed brick lime mortars of this period are supporting domes and vaults. In Christianity, we have the era of Byzantine architecture, which is connected with monasteries and other historic complexes, which are combining, apart from stones and brick, mortars, plasters, wood, and very advanced and elaborated structural systems. In the post-Byzantine period, the same materials and constructions are developing in urban scale. Neoclassical architecture of 18th, 19th century is combining stone, wood, fired ceramics with plasters and is developing new buildings prevailing in the urban texture. In the Industrial Revolution era and the modern and postmodern architecture, we have new materials. We are moving from cast iron and common steel to high strength steel to advanced light materials capable to bear very high loads with strength. And this is developing new capabilities in construction industry. Of course, in details, we will see in topic 2.5 the historic building materials, the stones, the ceramics, the mortars, whereas in topic 2.6 we will have an overview of historic materials of architectural surfaces like works of art, giving emphasis in mosaics. The major question, how do materials affect the behavior of structural systems? The example of earthquakes, where we have a ground velocity in ground acceleration. We are observing damage to occur when the ground velocity at a maximum exceeds 10 millimeters per second. According to the international standards, DIN, strong buildings can withstand from 5 to 30 millimeters per second ground velocities, whereas the historic buildings can stand only ground velocities between 2 and 5 millimeters per second. As we can observe in the fragility curves, when a structure has sustained prior damage or the material properties have deteriorated due to aging or decay, it is possible to exceed a specific damage threshold for any given ground acceleration and to have an increased possibility of damage. However, on the contrary, the amelioration of materials properties like of the modulus of elasticity, it might give us the possibility to diminish the damage level and the possibility of attaining damage. The role of material properties can be assessed by finite element modeling And here we can see by a model developed by Professor Chuck Mack of Princeton University, the assessment of the behavior of Hagia Sophia in a very realistic approach through estimating the properties of the pairing mortars. In the same way, we can elaborate proper scenarios and to select the best one for repair mortars, and according to them the proper intervention works to protect from earthquake the monuments. This happened in the case of Hagia Sophia within the context of cooperation between material engineers from National Technical University of Athens and civil engineers from Princeton and Boğaziçi University in US and in Istanbul in order to perform protection from earthquakes as intervention works by repair mortars before the big earthquake of August 99, which sustained the monument with the responsibility, of course, of the Directorate of Hagia Sophia Museum. The major question is why do we have to document and diagnose a building? What is the reason to know the changes through its lifetime? And what is the impact in our days of this study? It is of great importance to all of us to understand that the lifetime of materials and structure is limited, and facing a great environmental crisis today, we are facing a crisis of materials and structures of our civilization. Modern structures of reinforced concrete are experiencing the end of their lifetime, since it is predicted that they have a lifetime of more or less 70 years within an aggressive marine and polluted atmosphere. That means that the massive urban development that took place between the two World Wars and mainly after the Second World War is now facing its time limits. Historic buildings and monuments which arrived intact after thousands of years, through millenniums, up to date, are teaching lessons of sustainability. On the contrary, incompatible conservation interventions and repairs with modern, advanced but incompatible materials to the historic ones are threatening historic structures and are limiting their lifetime. In Knossos, an ancient palace of the Mycenaean period, arrived from 1500 before Christ up to date, but after the restoration of Evans in 1920s, it proved to end its lifetime at the end of the 90s. Due to the compatibility of the modern cement concrete with the historic materials, and due to the end of the lifetime of cement concrete. Since the 2000 restoration of restoration was imposed due to the limited lifetime of the Evans restoration. It seems that the lifetime engineering is the engineering which is taking lessons from historic materials and which is absolutely necessary in order combining human, financial, environmental, and social factors to maintain and preserve the built environment of today and bring it into the next century for the next generation. Functional life and economic life of materials and structures are under consideration in order to take decisions which will be viable. The diagnosis of decay should follow an integrated methodology, which is presented in Module 3 in the topic 3.6, employing non-destructive techniques in situ and instrumental laboratory techniques, which are permitting to search out the mechanism of decay and to assess and evaluate proper materials and conservation interventions. This integrated methodology is examined in the very concrete example of the medieval city of Rhodos, acting as an open lab, in order to give answers. How can we decide on whether or not to intervene to protect the building? The monitoring of materials life cycle is a warning for necessary interventions. The scientific support to a proper decision making concerns the decay diagnosis, the assessment of materials and conservation interventions in order to take proper decisions, which will have to be searched out in pilot applications in situ in order to assure innovative applications and in order to inform society and to assure that this application will be acceptable and viable. In the question, how do we intervene on a building? In topic 4, we have all the spectrum of intervention, conservation interventions, and more specifically concerned with our studies on the diagnosis of decay, we are dealing in 4.5 with compatible materials and conservation interventions, in 4.6 with criteria and methodology for cleaning and pilot applications, in 4.7 with criteria and methodology for consolidation in pilot applications, and in 4.8 with reverse engineering performing repair mortars with concrete case studies. Finally, the integration of all the diagnostic and all the conservation studies is performing the conservation, repair, reconstruction, and restoration of historic buildings and monuments based on the existing knowledge. The question finally is, how can we manage and use an historic building, a site, a monument, a complex in compatibility with its values? A very important presentation regarding values and awareness can be seen regarding the Acropolis of Athens as well in Module 1. While in Module 6 we can exert specific case studies for management and use. I cannot declare that technology is the only requirement to keep heritage alive. Not at all. It is a requirement for a proper approach. Knowledge, innovation, technology are available. but the priority is given by social awareness and youth initiatives. If they are not there, the boat cannot initiate new roads in the sea of keeping heritage alive. Education. Education is the major tool for social awareness and for youth initiation. eLAICH in Euromed context is a pilot which is by educating youth, developing mutual understanding between people and nations with different histories, religious beliefs, cultures, is developing peace as a prerequisite to sustain world's cultural heritage, transpassing frontiers and civilizations.